Hello everyone, I hope you all are doing well. So in today's video, we are going to start with our chapter 12 of class 10th mathematics, that is surface areas and volumes. In the previous chapter, we learned about circles and areas related to circles. Okay. So this is our probably the second last chapter because the chapter 13, that is the statistics chapter, I'm not going to cover in this playlist. I'm so sorry for that due to some of the reasons. Due to some reasons. So you can do it on your own. It is a very easy chapter. If you wish that I should cover the chapter, then please let me know in the comment section. I will definitely try to make a video on that chapter as well. But probably this is our second last chapter of this playlist, that is surface areas and volumes, and the last video would be for the chapter, would be of the chapter probability. That is the chapter 14. Okay. So we are skipping the chapter 13th in this video, in this playlist. Okay. So this is our chapter 12, that is surface areas and volumes. It is a very small chapter. It does not have many concepts in it. Just you need to visualize things, apply the formulas, and you'll get the answers easily. Okay. So let's get started. In class 9, you have come across figures like cuboid, um, cone, cylinder, and sphere. So basically, this is the cuboid. This is the cone. For example, cone, you may know, you might have seen the birthday caps. So they are typically they have a cone figure. Then this is the cylinder, maybe a bottle or something like that is a cylinder, and this is a sphere. It looks like a circle because we are viewing it in a 2D form. We are viewing it on a paper, so that is why it looks like a circle, but it is a sphere. Okay. So we have also learned the formulas to find their surface areas and volumes. Okay. We have also known the formulas to find their surface areas and volumes. So what are just to quickly revise, what are the surface area? If there is a certain figure, let's say I have a bottle, okay, I want to gift wrap this bottle. So the area that I need to cut from the paper is the surface area. Basically, the paper that I'll need to cover this bottle from all the sides, from this side, from the top side, from the bottom side. So that is called as the surface area of this bottle. So this bottle is typically a cylinder and maybe a hemisphere at the top and at the bottom. Okay, that will learn later. So that is called as the surface area. So you may see that this is the surface of the bottle. So that is why the area that can be covered by a paper or something like that to cover this bottle totally. That is called as the surface area of this bottle. Okay. Okay, so now what is the volume? So the amount of water that can be poured into this bottle is known as the volume. Volume can be defined as the capacity of a certain figure or a certain shape to hold something into it. So we'll just quickly see the definition of surface areas and volumes. So surface area refers to the total area that the surface of three-dimensional object occupies. So if this is my bottle, this is the surface. This is a 3D figure, right? So for this 3D figure, the total area that the surface of this three-dimensional object occupies, this area, this part, all this part is called as a surface area. While the volume measures the amount of space that an object contains. So basically, the amount of water. Now it is a bottle, so we'll obviously be pouring water into it, right? This is a bottle, so that is the amount of water in particularly in with respect to this bottle is the volume. Okay, but in general we can say that the volume measures the amount of space that an object contains. इसमें कितना space contain हो सकता है? If I fill some air, so the amount of air that can be filled into this object or bottle is known as the volume. Okay. So yeah, so that is what we refer to as surface areas and volumes. And you know that the area. If my dimensions are in meter, then the unit of surface area is meter square and unit of volume is meter cube. Okay. I hope that is clear. We'll quickly revise the formulas for the surface areas and the volumes of all the shapes. So let's start. I'll write the volume over here. Volume, surface area. I'll have my shape over here. So let's start with cuboid. Cuboid. Then we have cone. Then we have cylinder. Then we have sphere. Right. So now the volume of cuboid is length into breadth into height. Okay, so the all these dimensions would be given in the question. The surface area for cuboid is 2 into LB, length into breadth, plus breadth into height, plus length into height. Then the volume for cone is 1 by 3 pi r square h, 1 by 3 pi r square h. You know that the value of pi can be taken as 3.14 or 22 by 7. And the surface area for the same is pi r L plus r plus r square. Okay. Here r refers to the radius of the cone. So therefore, r can be for this circle, that is the radius of the cone. Okay. Now for cylinder, my volume is pi r square h. The surface area is 2 pi r into h plus r. And for sphere, my volume is 4 by 3 pi r cube. Surface area is 4 pi r square. Sure. Okay. I hope that is clear. So we'll quickly, we just in this chapter we need to learn how to calculate the surface areas and volumes for a mixture, a combination of all of these figures, like combination of cuboid, a combination of cone. You might have some figure maybe as in if we have a capsule that you may know the medical capsule we have, medicine capsule we have. So that is in the shape of like this, right? Its shape is like this. So that medicine capsule can be broken down into three figures, if we say that. So this middle figure is the can be taken as cylinder, and these two ends of the capsule can be taken as half, can be taken as semi hemisphere or just hemisphere, right? Hemisphere. Okay, or two half sphere. So if we combine these two ends, we'll get a sphere only, right? So we'll quickly see an example how to calculate those. Just for your reference, I'll also get include the formula, that is the total surface area of a new solid is equal to the um, curved surface area of one hemisphere plus curved surface area of cylinder plus curved surface area of other hemisphere. Here also they have taken a tablet. So for a tablet, you can see this is a tablet, right? It can be broken down as a cylinder, one cylinder and two hemispheres. Okay. So therefore, to get the total surface area, we need CSA, that is curved surface area of all of these three parts that we have broken down from the figure, that we have derived from the figure. Okay. Let's take an example quickly so that we can finish our topic now of at least surface areas. Okay. That example one is Rashid got a playing top, that is Lattu. You may have seen a top, the one uh, we just cover it with a thread and then we drop it on the ground. Top or Lattu, just to visualize you the figure. Yeah, this is a top. So typically we can consider it. as a as this figure, okay, which is a triangular figure from the in the bottom and a hemispherical figure in the top at the top. Okay. So therefore, Rashid got a playing top lattu as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 centimeter in height, and the diameter of the top is 3.5 centimeter. Find the area he has to color. So you know that now the he has to color the top. Okay, so basically, if I want to color this bottle, so I'll require the area that I'll require the total surface area of this bottle, right? So therefore, we need to find out the surface area of this figure. Now they have the question tells us that there is a hemisphere that is surmounted is basically एक के ऊपर एक रखना. So basically this bottle is surmounted on my head. So they are saying us that the hemisphere is surmounted on a shape that is somewhat like cone. So maybe we can refer it as this is a cone maybe, and therefore on the top of it we have a hemisphere. So it can be referred to as ice cream cone as well, right? Okay. Now the dimensions that are the data given data for us is that the total height of the top is 5 centimeter. That is from this to this, and the diameter of the hemisphere is 3.5 centimeters. So therefore, the radius would be 3.5 upon 2 centimeter. Okay. Now you can refer R of therefore the radius of cone and the radius of the hemisphere is same. Okay, because they are surmounted on each other. Okay, this is hmm. Now we need to find out the total area that Rashid has to color. Now this top so now the total surface area of the toy would be the curved surface area of the hemisphere plus curved surface area of the cone. ठीक है. Now the curved surface area of hemisphere is equal to 2 pi r square. ठीक है. This is the formula. You need to learn all of these formulas. Substituting all the values, we get the curved surface area of hemisphere as this. That is 2 into 22 by 7 into 3.5 upon 2 into 3.5 upon 2. Now you may notice that we have used the value of pi is equal to 22 by 7 and not 3.14. That is because we are given with the diameter as 3.5, right? So if I can cut down these 3.5 and 7 easily, I can divide them. And also the question had told us ki take pi is equal to 22 by 7. So that was also a reason to take pi 22 by 7. Now, next up we have also the height of the cone is the height of the top minus the height of the hemispherical part. Now, this is a hemisphere, right? If I complete it by making a sphere, now the diameter is 3.5. So therefore, this total part is 3.5 centimeter, right? But for the hemisphere, the height would be this much only, this much. So that is 3.5 divided by 2. That is the radius of the hemisphere. So therefore, the height of the hemisphere can be taken as the height of the hemisphere can be taken as the radius of the sphere or the hemisphere. Okay. So therefore they have taken it, and now we want to find the height of the cone. We need to find this height. So if we subtract the height of the hemispherical part from the total height, we get the height of the cone, that is small h. So they have done the same thing, that is 5 minus 3.5 upon 2 centimeter is equal to 3.25 centimeter. Now they want to calculate the slant height of the cone. Slant height is basically this height. They want to calculate this height of the cone. So the formula for the same is under root r square plus h square. R is the radius of the cone and h is the height of the cone. So substituting all the values, we get 3.7 centimeter, approximately the slant height of the cone. Therefore, now the surface area of the curved surface area of the cone is pi r l, where L is the slant height of the cone. So therefore, substituting the all the values, we get this part. Now we just need to add the two derived calculations. That is, this was one, that is curved CSA of hemisphere, curved surface area of hemisphere, and the curved surface area of the cone. If we add both of them, we get approximately 39.6 centimeters square. So therefore, the total surface area for this figure was 39.6 centimeters square. One more thing that we can notice over here, that the total surface area of the top was not the sum of the total surface areas of the cone and hemisphere. Okay, if you take, if you say I have two figures um, that are hemisphere and a cone. So therefore, we cannot add directly the total surface areas of both the figures and directly get the area for top. Okay, you need to apply some logic also. So this is the concept of surface areas. Moving further, we'll cover one example on volume also. So we'll directly go on a question and solve it. Example 5. That is, Shanta runs an industry in a shed which is in the shape of cuboid surmounted by a half cylinder. Okay. Okay. So basically, I have a in 2D we can say that I have a cuboid. Maybe it can be referred as rectangle, and I have a half cylinder over it, like half cylinder. No, if I close it from the bottom side, I'll get a full cylinder. If you cut this bottle in half from this part, you'll get a half cylinder. That would be this much only. So, if the base of the shed, now coming back to the dimensions, coming back to the question, if the base of the shed is of dimension 3 meter, 7 meter into 15 meters, and the height of the cuboidal portion is 8 meter, find the volume of air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube, and there are 20 workers, each of whom occupies 0.08 meter cube space on an average, then how much air is in the shed? Okay. So now the dimensions are, the height of the cuboid is 15 meter, and the breadth of the cuboid is 7 meters. Okay. The base of the shed is of dimensions. Okay. So maybe it can be referred as length into breadth also. So this is what we are given. And also, sorry, the base of the shed is of dimension 7 meter into 15 meters. Huh. And the height of the cuboidal portion is 18 meters. So length is 15 meters, breadth is 7 meters, and the height is 8 meters. ठीक है, cool. So from here, from the figure, we can also refer it as the height of the semi-cylinder, half cylinder, is also 15 meter. ठीक है, cool. And the radius of the cylinder is 3.5 centimeter, because you know that if I cover this part also, this is the diameter for the cylinder. Okay. So now if we divide it by 2, I'll get this much part, and that is the radius of the cylinder, that is 3.5 centimeters. We'll directly calculate the volume first to find out the air hold that the shed can hold. Okay, the volume of the air, coming to the solution, the volume of the air inside the shed when there are no people or machinery is given by the volume of air inside the cuboid and inside the half cylinder taken together. Now the length, breadth, and height of the cuboid are 15 meters, 7 meters, and 8 meters respectively. Also, the diameter of the half cylinder is 7 meter and its height is 15 meters. So the required volume is the volume of the cuboid, because we are covering the whole cuboid, and half volume of the cylinder, because we have only half cylinder over there. We don't have a full cylinder. Substituting all the values into the formulas, I get volume of cuboid is length into breadth into height, that is 15 into 7 into 8, and then we have half of the volume of cylinder, that is half into pi 22 by 7 into r square into h. pi r square h is the formula for the volume of cylinder. Calculating it, we get 1128.75 meter cube. So therefore, the area that the shed can hold is equal to 1128.75 meter cube. Now, the second part of the question was, if we have some machinery of volume this much, and some men of or some workers of volume this much, of individual volume of 0.08 meter cube, and there are 20 workers, how much volume is left for the air, or we need to find the remaining volume of the air. So we just need to add both of these volumes and subtract it from this total volume. So that comes up approximately 827.15 meter cube. I hope this is also clear. This is how we calculate the volumes for a shape that is a combination of standard cylinders, cuboids or spheres or cones. Okay. I hope that is clear. Just memorize all the formulas and visualize things, and just find out what do you need to calculate and how are you going to calculate it, and just substitute all the values into the formulas, and then you'll get the answer very quickly. That's it. This is only what we need to learn from this chapter, that is surface areas and volumes. I hope all the concepts are clear, and you have understood the explanation as well. If you have any doubts, put it in the comment section, and go through all the solved examples, solve the exercise questions also. And that's it for this chapter. See you in the next video. Thank you so much for watching this video. Take care, bye bye, and have a good day.
वीडियोस बनाने हैं, फिल्मोरा है ना।